Hey everyone, my name is Joe, and this is the Tempo session at GrafanaCONline 2021. So hopefully you're here to learn about Tempo, our distributed tracing backend, or distributed tracing generally. We're kind of be talking a little bit about both. So distributed tracing generally, to just kind of lay some groundwork here, is a method of recording a query as it passes through your system. Each service kind of offloads these things spans to our backend, and we rebuild those and use them to construct and visualize the path that a request took as it passed through all of our systems. This is great for diagnosing long tail issues. So like you can find queries that were kind of in your P99 that took maybe several seconds instead of milliseconds, and determine where it was spending its time and hopefully why, and direct development efforts. Tracing is also great for triaging issues to find a request that's failing and maybe determine why it's failing, or also for gaining information about our infrastructure or many other things. T is for Tempo. Tempo is a inexpensive and high volume tracing backend. So this is kind of what we announced at the ObservabilityCon last fall. So the idea was to store traces in an object storage, so GCS or S3, and to store this extremely high volume of traces in a very inexpensive way. We are OpenTelemetry, Zipkin, and Jaeger compatible. So all existing open source instrumentation, if you're already instrumented, or open tracing, of course, then we are set up to consume your traces. Excuse me. And it's also a trace by ID store. Kind of a key feature is that when you store traces in Tempo, you can only request them back by ID. So at Grafana, we use two methods of finding our traces. One is through logs and one is through metrics. We'll talk a little bit about these throughout the session. Through logs, we are going to, on the same log line as a trace ID, record other information like an HTTP status code, or a duration, or a path, or a HTTP method, or anything else that would make sense that we might want to look up our trace by. The idea here is that we have this very flexible method of indexing our traces. And when we built Tempo, we found that we were mostly finding our traces through logs anyway. So it made sense to not kind of pay for another expensive index. Instead, just use our existing tracing backend, Loki, find our traces through logs. And then if we built this trace by ID store, everything would work. Secondly, we find traces through exemplars. So an exemplar is an example of a request that was aggregated away to create a metric. So a given metric might represent hundreds or thousands or tens of thousands or even millions of requests. And sometimes, or all the time, I guess, the details are lost when you aggregate those, when you aggregate that away and just get this nice description, this nice curve of latency, for instance. So an exemplar is taking a piece of metadata, a trace ID in this case, and associating it with the metric so that we can then request it back later. So we can, on any given metric, on any dashboard, or in Grafana Explorer mode, we can immediately jump to a trace that was kind of that was aggregated away to create that metric. So over the past few months, we have been adding more stability, additional features. We have been adding compression, reducing cost of TCO, or total cost of ownership, as well as increasing stability and kind of getting Tempo ready for its next steps. And at ObservabilityCon, I announced 170,000 spans a second, which we were quite proud of, but now we're sitting at 2 million spans a second, or 350 megasecond. We are currently storing 132 terabytes of compressed trace information in our backend, and we are, which is 74 billion total traces in the backend. And our P50 is about 2.2 seconds. So we're very proud of these numbers. We're always trying to push Tempo farther in this manner. Kind of the core of Tempo I always see as being about scale and about being this massive trace backend built on top of object storage to keep it inexpensive and operationally simple. But right now we're announcing something very cool, which is Tempo 1.0. So Tempo GA, all of this work for the past few months, adding the scale and stability, has been letting us offer hosted Grafana tracing in Grafana Cloud, and also cutting Tempo 1.0 of the open source project at the same time. So you can now pay for hosted tracing. We had previously had a free beta, but now we have a paid hosted tracing product that you can use for your distributed tracing needs. We have a free and pro tier. So in the free tier, you can get, if you're using the free beta now, you can transition to this. It has 50 gigs of free traces a month and a 14-day retention. And then our pro tier is 100 gigabytes of traces included with the package, and then 50 cents per gigabyte overage. And there's a 30-day retention on the pro tier. So if you're already using free beta, you'll just slide right into the free tier here. And if you're not, please jump in, check out the free beta, check out the pro tier, and hopefully we can start, offering hosted tracing for you, and hopefully that'll, meet your needs and you can use our tracing service. So in this session, we're going to be talking about a few other things. Mario is going to be talking to us about some of the features available that we're announcing today, available in Grafana Tempo and in the agent. Callum is going to be talking about exemplars, the state of exemplars, and how far we've come in terms of offering those in both Prometheus and in our backend Cortex. And then Marty is going to be talking about the future of Tempo and and kind of the vision over the next 6 months, year, 18 months, and kind of where we intend to take Tempo over the next bit here. I'm going to hand this off to Mario, and he's going to be talking about some of these features. Thank you for joining us. I hope you have a great conference, and take it away, Mario.
Hi, everyone. My name is Mario. I'm a software engineer at Grafana Labs, and today I want to talk about 4 things. First, I want to talk about the Grafana agent. So what is tracing pipeline and where does the Grafana agent fit in? Then I want to talk about automatic logging for trace discovery with Loki. Next, I want to talk about tail-based sampling. And finally, I want to talk about generating metrics from spans. So what is the Grafana agent? Before, if you wanted to use Tempo, you would instrument your code and then you have to do some custom work to collect all the traces and forward them to Grafana Cloud or your tracing backend. And this is what the Grafana agent solves. The Grafana agent is a push-based agent built using OpenTelemetry that can collect all your traces and forward them to Grafana Cloud or your tracing backend. Now, the objective is that you only have to drop this in place. This means that you can get your spans into Grafana Cloud almost trivially. So once you have instrumented your system with distributed tracing, it shouldn't take longer than a few minutes to drop in the Grafana agent and start seeing spans arriving in Tempo. The Grafana agent also brings other features like trace buffering, retries, and more features that I want to talk about next. And one of them is automatic logging. So running distributed tracing systems is very powerful, but it also brings its own set of challenges too. And one of them is trace discovery. As today, Tempo supports finding a trace if you know the trace identifier beforehand. But Tempo does not yet support native search of traces. So we leverage other tools like logs and metrics through, for example, exemplars for trace discovery. And exemplars provide a way to navigate from metrics to traces to logs in all directions. And Callum is going to talk about this in a moment. But leveraging other tools for trace discovery is not always easy, or it may be more work than you're looking to do. This is why we've made this an out-of-the-box experience that is really easy for you to make use of. And so we've introduced automatic logging in the agent's tracing pipeline. And what automatic logging does is it writes a well-formatted log line to a Loki instance for each span, root span, or process that passes through the tracing pipeline. What this allows is to automatically build a mechanism for trace discovery. And on top of that, you can also get metrics from traces using Loki. So how it works is automatic logging searches for a given set of attributes in the span data and logs them as key value pairs. Then this allows us to search by those key value pairs in Loki. So in essence, automatic logging leverages the powerful tool that is Loki to provide a simple way of trace discovery. if you already have Loki configured in the agent, you just need to get the tracing pipeline to use it and start pushing trace logs to Loki. We've also built an integration for it in Grafana. So once you have found the trace you're looking for instance, looking for duration longer than 2 seconds and that it contains an error, you can open the log and you can click the blue tempo button that will redirect you to the tracing UI that will show you the trace in full. Right, next I want to talk about tail-based sampling. So Tempo aims to provide an inexpensive solution that makes 100% sampling possible. But sometimes constraints will make a lower sampling necessary or desirable, such as runtime costs or egress traffic related costs. And usually you can easily apply a sampling percentage to your instrumentation. But with that, you run the risk of discarding relevant data that you will later want. So ideally, what you want to do is, if you have to discard data, you want to discard the less relevant data. And that is what tail-based sampling does. So in tail-based sampling, the sampling decisions are made at the end of the workflow. So when you have all the trace data, you make a more intelligent decision based on that data. And we've recently added support for tail-based sampling in the agent's tracing pipeline. Now you can design a set of policies, and the agent will sample based on those. For instance, you can inspect if a trace contains an error, and based on that, decide if you want to keep it or discard it. Most likely, you will want to keep it. Obviously, this also brings challenges too. One of them is for tail-based sampling. In multi-instance deployments, spans for the same trace can arrive to different agents, but you need all the trace data located in a single place in order to make the decisions. So we've made it possible to distribute traces across agents instances by consistently exporting spans belonging to the same trace to the same agent. So the data consistently arrives to the same place. And finally, I want to talk about generating metrics from spans. We've introduced this feature that we call span metrics that allows you to generate metrics from the tracing data automatically during the tracing pipeline in the agent. So span metrics aggregates request, error, and duration metrics from span data. These metrics are exported in Prometheus formats, and there's actually two options available for exporting these metrics. One is using remote write to a Prometheus compatible backend, and another one is serving the metrics locally and scraping them. Span metrics generates two metrics. One is a counter that computes requests, and a histogram that, and another one is a histogram that computes operations durations. Span metrics can be of particular interest if your system is not monitored with metrics, but has distributed tracing implemented. Basically, you're getting out-of-the-box metrics just from your tracing pipeline automatically. And even if you already have metrics, span metrics still can be very useful to provide more in-depth monitoring of your system. So the generated metrics will show application level insights into your monitoring. So for instance, if your tracing is being propagated down to the application's persistence and caching layers, your span metrics will too, as shown in the screenshot. We're seeing memcache and GCS operation-related latencies. And also, span metrics can be very useful, providing visibility on traffic patterns to the tracing backend. So if your Tempo instance is receiving more traffic than usual, you can quickly check where the increase of traffic is coming from. Well, and that was all from my side. Thank you for attending, and I will leave you now with Callum.
Thanks, Mario. Hi, everyone. My name is Callum, and let's talk quickly about exemplars. So first, we'll go over what exemplars actually are and have a look at some of them with some examples. Then I'll quickly cover what's changed in the last 6 months since the last time I gave a talk about exemplars. Then I'll show a quick demo of jumping straight from a metrics query to a relevant trace using exemplars. And then finally, we'll go over what you need to do yourself in order to start using exemplars today. So what is an exemplar? Exemplars are essentially higher cardinality metadata, data from a specific event that you can associate with traditional time series data. So some examples of metadata could be trace IDs or CICD build numbers. You may have heard of this technique already, either at our past Grafana Observability Con, or maybe as part of a talk at Google Cloud Next 2018 called Improving Reliability. Exemplars enable the workflow we at Grafana Labs as operative software have always wanted. Exemplars make observability of your system easy, giving you a direct link between metrics you view in a graph and a trace that shows you the execution path of a particular request. So you as the user of code instrumentation libraries can decide when and where to generate exemplar data. For example, you may only want to generate exemplars for requests that resulted in errors or particular status code. This is where the fields of the exemplar itself can help you. The labels field takes in free-form key value strings for any metadata you think is relevant. There is a maximum length in characters for these labels, and the labels must comply with Prometheus's metric and label name model. So for example, this is where we add in something like the trace ID for a given request. The exemplar value is specific to the metric type you're associating the exemplar with. For example, the metrics here are histograms. They're tracking the number of events that fell into certain buckets, say request latencies. And in the case of the exemplar, the value is the value observed that counted as an event within that particular bucket. You also have the option of exporting a specific timestamp as part of the exemplar. And this exemplar format that I'm showing you here is part of the official Open Metrics spec. So if you want to have a look at that, you can do so on their GitHub repository. So what's new? Last time I spoke about exemplars was at Observability Con, I want to say in October. And at that time, exemplar support in various projects was working, but not necessarily merged upstream or distributed as part of any stable releases of those projects. So I'm happy to tell you that at this point in time, both Prometheus and Cortex support ingestion and querying of exemplars. And Thanos will also support federation of exemplar queries to all of the Thanos sidecars and Prometheus instances that you have set up. So there's still more work to come in terms of the storage efficiency of exemplars themselves in all these projects. And for those of you who are interested, I've included links, or I guess in this case, just PR numbers to the relevant pull requests if you're interested in looking at the implementations. So let's have a quick look at a demo. The Prometheus data source within Grafana, which in this case is one of our internal Cortex clusters, is now set up to also send an exemplar query in addition to the regular PromQL query. So the query I've got here looks at the 99th percentile latency of requests within Cortex, and we're looking specifically at our query range endpoint or route. So let's imagine that I've been paged in the middle of the night for this endpoint's error budget. And I'm trying to figure out if maybe there's a particular instance of a service that's that's resulting in the errors. So here we can see the result of this query. We've got the regular legend at the bottom of all the series and with all their series labels. The graph has got the normal lines with a sample at each timestamp. But what's new is we've got these diamond icons, and each of these is an individual exemplar at a timestamp. And by mousing over one, we can see all the details for that exemplar. So looking at the data for the exemplar, we first got the 3 fields that I showed you from the exposition format, the timestamp, the value, and then any labels, in this case, the trace ID. And all of the remaining data is actually the label set for the time series that this exemplar was associated with. Remember before I mentioned that exemplars are a way to associate metadata with a given time series. So you've probably noticed the blue query with tempo button next to the trace ID. This is a feature of the Prometheus data source that allows you to specify another data source and label from the exemplar to use to query for additional data based on the contents of that label. So here we've configured our Cortex Prometheus data source to query our internal trace storage tempo by passing the tempo query API the trace ID field's contents from these exemplar labels. So when I actually click query with tempo, it's passing that trace ID directly to the query endpoint for that data source. This whole process means that when I've been paged for this query error budget burn in the middle of the night, I can jump straight from my ad hoc metrics query to a relevant trace without having to necessarily write any additional queries, especially additional queries to other data sources myself. Without this, I'd probably at the very least have to go digging through logs trying to find trace IDs from a specific service. So this makes that whole process a lot easier. Now, at this point, you're probably wondering what changes you need to make yourself in order to start using exemplars. So first of all, you need a more recent version of whatever client library you're using. The Go, Java, and Python clients all support exemplars right now. So for example, in the case of the Go client, you previously would probably have calls like add or observe. With exemplars, you'd want to use add with exemplar or observe with exemplar. And I mentioned the data source linking. So the Prometheus data source now has this exemplars section where you can link to another data source and tell it which label to look for in the exemplars. So this is actually a screenshot of the data source that we used in my demo. And then you'd also need to actually update your instrumentation, right? So this is also code that resulted in the exemplars from the demo that I just showed you. Before we had exemplars, we simply had an observe call to record the duration of HTTP calls to Cortex in seconds. And now we've got this little wrapper that basically checks to see if the request's context contains a trace ID. And if it does, then we call observe with exemplar and pass that trace ID in as well. Otherwise, we just call the regular vanilla observe. And that's it for me. Hope you learned something about exemplars. Let me know if you have any questions. And with that, I'll pass off to Marty. Thanks.
Thanks, Callum. Hi, everyone. I'm Marty DeCibio, and I'm a senior software engineer at Grafana Labs, and I work on Tempo. Today, I'll be showing you some of the things that we have in store for Tempo and tracing. Tempo is currently only looked up by trace ID. It's kind of a chicken and egg problem. And that means that your tracing journey can sometimes have a rough start. You have to rely on another source of data to find the trace IDs so that then you can look up the trace in Tempo. The main way to do this today is with application logs. You log a message for an event and you include the trace ID and other bits of data that are important. By searching the logs, you can discover your traces. This is trace discovery. Now you can start using exemplars too. These methods are solid and they work well, but we would like to do more. That's why we will be adding native search to Tempo. There's been a ton of interest in this from day one. Our approach will be based on a query language inspired by PromQL and LogQL. So it will be very full-featured and familiar and easy to pick up. Searching will be oriented towards finding traces, not spans. So we will have powerful abilities to look at what's happening between and across spans and other high-level attributes of the trace. It will have what we're shooting for high speed through massive parallelization instead of heavy indexing, meaning that it will work well for different workloads. Here are some examples of what a query could look like and the kinds of questions we want to be able to answer. This query finds traces with a cluster tag of prod and a duration longer than 5 seconds. Other queries we'd like to ask are, find a page load with more than 10 calls to the backend, or find an API call that missed the cache. We should be able to derive metrics from the search results similar to Loki and other log platforms. All right, that's Tempo native search. Let us know what queries you run today or would like to run. We want to hear from you. Exemplars. We just heard the latest news on exemplars from Callum. A lot of great work has been done. There's even more we would like to do. The current implementation is in memory only and thus short-term retention. We will start working on long-term persistence to disk so that exemplars can be stored as long as the metrics are, months or even years. We saw the new library methods to observe exemplars, and what we need is better support for more languages and platforms. Finally, we expect deeper integration of exemplars into the many common instrumentation libraries so that a lot of metrics will have exemplars out of the box. Service graphs are a way of mapping out interdependencies from the tracing data. These are very cool and are something we would like to bring to the Tempo world, but with a specific approach. Instead of heavy processing of trace data after the fact, we want to record metrics representing the edges and nodes on the fly as the data is ingested. This approach has some advantages. It builds on top of long-term storage and query capabilities for metrics. Results should be fast to produce, and it also provides a time component automatically. It would be straightforward to compare or see changes in the graph over time or derive metrics from the graph data. To push it even further, we could record exemplars for each edge or node, and we could quickly see traces that activated that part of the graph. Tempo has improved a lot since release, and there have been amazing improvements both in scale and efficiency. As Joe described, our internal tracing volume has grown from 170,000 spans per second to over 2 million. We measure tempo efficiency with a metric called spans per second per CPU core. This is how we know Tempo is performing well at workloads of any size, large and small. Through more efficient data structures and other fine-tuning, we have improved Tempo's efficiency by almost 4x, from 2,000 spans per second per CPU to 7,500. The efficiency metric is important because Tempo was designed foremost as a high-volume, low-cost tracing backend. As we add new features like search or service graphs, it will be done in ways that keep this performance. All right, everyone, thanks for participating. We're really excited about Tempo and all these recent announcements, and we hope you are too. We would love to hear from you. Please get involved and join us in the community forums or the Grafana public Slack in the Tempo channel. Thanks.
Hey, everyone. So thanks for coming to this session. This is kind of the Tempo Q&A part, and we'll just go down through these questions. I'll start kind of at the top by upvotes. So if you are interested in a question, feel free to hit the little thumbs up button there. And our top question is, I think a common one, as a beginner on distributed tracing, what's the best place to get started? And Marty has already volunteered to field this one.
Hey, so we have a new Getting Started page in the Tempo documentation that walks through more than just Tempo, like just building up an entire tracing pipeline and the application changes. And it's really great. And I will post a link here. And I'm not sure if that will make it to the right spot. So
it will not.
Okay, yeah. So if you search for or go to grafana.com and look through the Tempo documentation, it's the first link. It's called Getting Started, and it walks you through the application changes and all the other components, all the way up to viewing traces in Grafana. Yeah.
Cool. So the next question is, what are the advantages of Grafana Agent over Promtail, how are they different? Did I volunteer to answer that one? I already have forgotten what I've said. Sure, I'll answer it. So Grafana Agent is a collection of telemetry tools. Promtail is actually a part of Grafana Agent. Grafana Agent wraps a Prometheus kind of metrics telemetry pipeline, Promtail for a logs pipeline, and then the OpenTelemetry collector for the tracing pipeline. So Promtail is meant for logs only, and Grafana Agent kind of encompasses that, and it's meant to be like an all-purpose telemetry tool to upload, to make it easy to upload telemetry data to Grafana Cloud. Can I use Tempo with the Grafana Cloud free plan? Yep. So what is it? I think 50 gigs, a 14-day retention, 50 gigs total total trace volume over that 14-day period for the free tier. So yeah, sign up for Grafana Cloud, and I think there's a free metrics tier and a free logs tier, and you kind of play around with all of those pieces and see, what works for you. Does an application need to add a piece of code for tracing like Jaeger? Does anybody want to handle that? Callum, does an application need to add a piece of code for tracing like Jaeger?
Yeah, I mean, I think that was probably in part during the exemplar bit. I mean, the short answer is yes. For everything we talked about, you need to have instrumentation to get the traces in the first place. Yeah. Yeah.
Some languages do have some kind of automatic capabilities, but like a Java, I think, does, and Python has some kind of automatic instrumentation. But you'll have to add at least like link to a jar or link to a library or add some lines of code somewhere to get some kind of instrumentation for sure. If you Google auto instrumentation, you'll find both open tracing and open telemetry libraries that do a fair amount of that. How do I use Tempo and exemplars with a vendor product? Can I instrument binary, which I do not have the source code for? No. The tracing part, no, for sure. I guess, well, I mean, there's like service meshes, which do a little bit of this. My experience is they do an okay job. Certainly instrumenting your code directly is a preferred path to getting logs, traces, and metric data, although I think service graphs can provide some amount of that kind of data. Mario, this one's for you. What is the resource increase seen in the agent using tail-based sampling, and what features of a trace can we sample on?
Right, nice question. Actually, that's difficult to answer. It will heavily depend on the load and the setup that you have. For our internal testing, we've seen that the CPU almost doubles because it involves redistribution and then inspecting the traces. And as for memory, it will, as I said, heavily depend on your setup. If you wait for longer for a trace, the memory increase, like the overhead, will increase heavily. And as for features, right now, you can sample you can rate limit and then sample by the spans attributes. We're working on adding new features like sampling based on latency or sampling based on the status code and so on.
Cool. Logs and metrics from traces, so no need for Cortex and Loki anymore. I don't think so. Certainly, deriving metrics from logs or metrics from traces is attractive, and there's a lot of power there. But nothing will ever beat metrics at being metrics. Certainly, in terms of like storing a single float and a single timestamp, I think Prometheus gets that down to bytes, like a very, very small amount of space per sample. And you'll never beat that in terms of efficiency of querying, as well as efficiency of storage. So metrics from traces and logs are cool, but they will never replace metrics, I don't think. It's just too cheap to store metrics.
I mean, to add on to that a little bit, I mean, the logs and metrics that are generated do have to go somewhere. And so that would still be Prometheus, Cortex, Loki, or something else, right?
Right. Does Tempo support Kiali and Istio tracing? So Istio supports Zipkin, I believe, tracing, and Tempo supports Zipkin, so yes. I do not know about Kiali. I'm not even sure I'm pronouncing that right, or what that is. I don't know if anyone else can jump in, or I guess that might be another service mesh. Tempo supports Jaeger, Zipkin, OpenTelemetry directly. So if Kiali is instrumented in any of those, it will ingest those spans. What is something that seemed impossible about a year ago when you started working on Tempo that has become a reality now? I don't know. What do y'all think? Exemplars?
Yeah, I mean, exemplars basically just made like our job, when we get paged, like so much easier. It was kind of not impossible, but more difficult than it needed to be to find a trace relevant to the thing we were getting paged for before. And this just exemplars and jumping from logs to traces as well just made that so much easier. Yeah.
Yep. So exemplar create. Okay, so I think this question is basically how does a trace ID get propagated through an exemplar, and what is it associated with? Maybe I don't know if Callum, you can handle that. Just like how is the trace ID consumed by Prometheus? What is it associated with? How do you query it? That kind of thing.
Right. So, I mean, your code has to be in some way generating a trace with a trace ID in the first place. And then in the Prometheus client libraries, instead of just using a call to observe a histogram, you observe the histogram with the trace ID, basically with exemplar, where you can pass a set of labels. And one of those labels would be the trace ID for that request. So whether it's part of your context in Go or something like that, you pass that value in. And then the Prometheus data source itself, so this isn't specific to Cortex or Thanos or anything like that, but basically anything that supports Prometheus's HTTP query API. There's in the Grafana data source, there's just a configuration field where you say, this is the endpoint that I want to query for exemplar. So it could be Tempo or Jaeger or whatever, as long as it supports a query by trace ID. API. And so you would just reference that label that you had put into your exemplars that is the trace ID, whatever you called it, right?
Cool. How much of a beard Joe could grow? How much of a beard can Joe grow? I don't know. Mario, I think you're an expert here. Can you handle that one?
Yeah, I don't know. I shave myself, so I don't have that much experience with beards.
I think we're really capping out here, honestly. I don't know if I could do much better than this. Between my wife and my children who get all annoyed by it, I just have to eventually trim it down. What does Tempo mean? What is the meaning behind the name? The meaning, really, we had about 3 different products named Tempo at some point. At one point, Loki was Tempo. I think even Cortex at one point was Tempo, although don't quote me on that. The idea being, you're kind of maintaining speed, perhaps, or kind of that's maybe the marketing angle of the name, that it's kind of implying you can maintain your rate of diagnosing an issue. And then it starts with T, and tracing starts with T, and Loki and logs and all that. Does Grafana have the ability to show the complex JSON structure from a log line as a tree with collapse expand actions instead of a plain text table? So I think this is more like a Loki question. You're asking, like, is there a way to kind of visualize a full JSON blob in something besides just a line? And I don't know. I don't think so. But if this is an important feature, feel free to file it on the GitHub repo, the Grafana GitHub repo. Of course, traces are displayed as a big tree, but I think this is more related to like a log, is how I'm reading that question. Callum mentioned you can use exemplars to link Cortex to any other data source. Have you used other sources except Tempo are you exploring additional use cases?
Okay, I think I kind of answered this a little bit as part of the last question. I mean, the short answer is that we definitely tested this internally with a Jaeger data source before Tempo was fully up and running. So yes, you can use the Prometheus trace ID exemplar type querying with basically any tracing backend.
Cool.
Yeah.
Yep. And sadly, we're out of time, and there's absolutely no way to answer any other questions in the list. So we're just going to go ahead and wrap this up. And thank you all for your time. Have fun at GrafanaCon, and we will see you when we see you.
Hi everyone, and welcome to this session. At Pernod Ricard, we manage multiple e-commerce websites deployed across the globe. And in this presentation, we will explain you how we monitor those Magento sites using Grafana and Loki. We will be available through the chat after this presentation, so we'll meet you there if you have any question. So we are 3 speakers on stage today. So Nikos Ravi, Digital Commerce IT Manager, Hakim Rouadbi, IT Solution Architect, and myself, Laurent Bell, Head of IT Architecture and Innovation. But before we deep dive into the details, there is a quick overview of where we come from in regards to our Grafana journey. So we started 3 years ago while working with a provider that was using Prometheus and Grafana as a monitoring stack. And we decided roughly a year ago to make it a standard component and extend its usage. But I guess the main reason why we are here is probably because we actually love the company's mindset, and inspired from the open source spirit, we wanted to kind of give back to the community and you guys. So here is the agenda for today. We'll start with the e-commerce strategy. Then we will present you our e-commerce stack, and then we will deep dive into Grafana and Loki technical setup. And I'll now hand it over to Tony to talk about the e-commerce strategy.
Thank you, Laurent. So I'm Tony. I'm a digital commerce IT manager at Pernod Ricard, and I help our affiliates deploying e-commerce websites. So I'm going to present you Pernod Ricard. So we are number 2 in wine and spirits industry. I believe you may know some other brands such as Jameson, Absolute, Havana Club. So we have more than 80 affiliates, among which we have brand companies, so the companies that are in charge of producing the product that we're selling, and we have market companies that are responsible of selling these products over the countries. And we have actually 5 consumer-centric channels. We have on-trade, which is in bar, restaurants, hotels, clubs. Off-trade, which is just a normal distribution channel, such as Carrefour or Walmart. Have hometainment as well, because we do sell services. Have travel retails, so it's basically when you go on an airport and you have like duty-free, you can indeed buy our product there. And finally, we have e-commerce, and that's actually the main topic that we would like to focus on today. So what about our e-commerce strategy? So we have 3 channels to sell online mainly. The first one, which is, let's say, the easiest one for us, it's through e-retailers, so such as Tesco, Carrefour. What we do is that we sell products to them, and then they are responsible of selling our products on the platform directly to the consumers. So here we're not taking care of everything, not delivering to the end user. We're just handing over to those e-retailers. The second one is the marketplace. So here, well, the main one that you may know, obviously, is Amazon. We have also Tmall. So here, what we are doing is that we are using those platforms to sell online to our consumers, but then we are taking care of the consumer service as well as the delivery. We also own our own Drinks & Co marketplace, which was acquired like 4 years ago, in order to for Pernod Ricard to really jump into the marketplace business. And the last channel that we are into is the direct-to-consumer channel. So obviously, since Drinks & Co is owned by us, so this is, let's say, one of our direct-to-consumer websites. But we have also some others, such as brand website like Ricard.com, RSRV, or also some internal website for friends and family employees or corporate website. Those websites are entirely managed by us, by Pernod Ricard. So it means that we build those platforms on Magento, as Laurent said, and then we are taking care of everything after. So as I said, like for the marketplace, customer service, logistics, but it means also that we need to make sure that the platform are up and running all the time. So since we are managing those platforms, it means that we have real key challenge that we face. So our first key challenge is to reduce time to market to our end users. And we need to keep profitability, obviously. So we have seen in the past years that there is a great opportunity for retail e-commerce. Just to give you some figures, in 2019, retail e-commerce accounted for 14%, while the prediction accounted for 22% by 2023. And it even accelerated more with COVID, obviously. So just to give you an example here, between March and mid-April 2020, US online alcohol sales counted for accelerated over 234%, which is huge. It means that we need to be there fast. But we can be there fast, but we have to build like a solid platform, because we need to keep first profitability, but also we need to keep being consumer-centric, which is, let's say, the core of our business. So it means providing great user experience, like 24/7. Our platform, needs to be always up and running. But in addition, we need to be able to collect consumer data for first better retargeting, but also in case of issues, we need to be able to log all the issues that our consumers may face on our platforms. The second key challenge that we have is building a replicable and scalable infrastructure. We have 80 affiliates. We need to be able to deliver a strong e-commerce platform to all those affiliates and in minutes. So we have built a platform to be able to bootstrap those new websites in minutes. In addition, we need to be able to provide a very scalable infrastructure in case of big campaigns. So we need to be able to scale it up on demand during Black Friday, for instance. We expect to have big peaks of traffic, so we need to be there. And during those specific campaigns, we need to be able to monitor and alert our DevOps teams at any time. So they need to be able to have the tool to just see what's happening on the platforms. The last key challenge is to be able to empower our developers with advanced tooling. Indeed, so those platforms are based on Magento. So it means that we need to provide a solid development environment to our developers. We need to also give them the ability to deploy whenever they want. No matter the availability of our DevOps team, we want our developers to be quite autonomous. And in addition, they need to be able to debug at any time as well. They don't need to rely on someone else to do that. So it means that we need to set up all the APMs and the logging system in place in order for them to be quite autonomous. So now I will hand it over to Hakim, who will present our e-commerce stack in a nutshell.
Thank you very much, Tony. Thank you, everyone, for watching our presentation. So my name is Hakim. I'm a solutions architect working at Pernod Ricard, and I'm one of the architects that worked on this platform, which I'm going to present to you right now. So this stack that we designed is based, as Tony said earlier, on the Magento e-commerce framework, with many custom in-house modules for interacting with external services, like the CRM or product information management or B2B and B2C authentication APIs. And our markets and brands can mix and match any number of these modules to make their websites tailored to their own needs. And the mixture of Magento and specific modules that we make is what we call a blend, actually. And then there is the packaging and deployment of these blends, which is done using Docker, which allows us to have reproducible environments. And we also use a promotion system. So when the development image has been validated by the developers, it gets promoted to the staging environment. And then once the tests are running successfully, it gets deployed to the production. And finally, the whole thing is deployed on AWS using the ECS orchestrator. But we also use many of their managed services extensively, like RDS for the database, Redis for caching and session management, Elasticsearch for indexing and searching products, and so on. So let's zoom in for a minute to see what the stack looks like in a bit more detail. So first of all, as you can see, all of the traffic goes through a CDN first, and then the load balancer and the web application firewall, or a WAF. So there's a lot of logs that can be already generated here and exploited. And we didn't get to the Magento part yet. Then we reach the application side, which is Magento and its modules, along with the cron jobs and any background jobs that need to be running on these ECS clusters. Third, we have the data persistence layer, which mostly relies on the managed services on AWS. So for example, RDS, Elasticsearch, and EFS for storing files. And then, of course, there is CloudWatch, which covers some of the monitoring and logging of the whole stack, which we will cover in a bit more detail later on. And finally, everything is deployed using Terraform, not only the infrastructure itself, but also anything that a store needs to run, like the load balancer configuration, the DNS configuration, SSL certificates, the backups themselves, and also the everything related to monitoring and logging. So we actually do provide this stack as a service to our affiliates. We actually call the whole thing the e-commerce factory, and it allows us to deploy new websites pretty much at the push of a button. And every website that we deploy comes, batteries included actually, so it has all of the integration that we need to call other APIs, but also everything that's needed to have a clear overview of how the site is functioning. And of course, all of this we put in place to try to minimize the time to market for our affiliates, so they're up and running as fast as possible. Geographically speaking, we have around 30 e-commerce websites. Each of them has 3 environments, sometimes more, spread across 15 clusters and 5 regions around the world. So the USA, Europe, Asia, Sydney in Australia, for Australia, New Zealand, and finally Beijing for mainland China, which is actually one of our biggest markets. So regarding the monitoring requirement that we have, first of all, we needed to have observability inside all of the stacks all across the world. We needed to know what's going on at every cluster level, what is the memory and CPU usage, and of course, all of the other useful classic metrics, we need to have access to them. What's going on the managed services level? Are we having some high usage of the database already because of some batches or background jobs or heavy API calls or anything like that? And then we need to have a per site overview. So what's the status of every single container? Are we having a burst of HTTP errors like 500 status codes? How are the cron jobs performing? Are we within the limit of the container reservation for CPU and RAM, or should we allocate more for some reason? And are there any pending tasks? And how long have they been pending for? Because when you have pending tasks on ECS, that means that if they last for long, that means pretty much that there is some issues going on, either with the installation of Magento somewhere or some deployment problems. And also, how do we get notified if there is a lot of these pending tasks? And finally, we need to have easy access to all of the logs, and we also needed to export them in some way to our development team, which doesn't necessarily have access to AWS. So Magento has some tricky ways of logging into multiple files, including some random generated files. So we need to have a flexible way of watching for directories in new files. And the challenges that we faced when we are putting this stack in place. So the complexity and number of stores is growing very, very fast. So like in the last 2 weeks, we had 4 new websites pretty much ready for production. Our team, however, is not. We are a small team, and we need to accommodate for this growth, very aggressive growth in real time. So without necessarily adding some overheads for us and more work. So we need to be flexible enough to handle everything without having more manpower in the team. We also needed to provide an easy access to the logs to our developers, which have many different backgrounds. So they need to have a clear way to find any line of log very quickly. And finally, we need to establish a common ground with the 24/7 team. We needed to speak the same language regarding logging and monitoring with them, so we can pinpoint any issue that can arise and understand each other very quickly. So some of the tools that we considered for this task, first of all, there was Prometheus, and everyone here pretty much knows Prometheus is a very powerful and flexible tool along with its ecosystem of exporters. However, the issue with Prometheus is not related to Prometheus, but the way that we would have used it for our own stack is that we would need at least 16 instances, both for the clusters and for federating everything using Prometheus. And we also found out that the ECS service discovery part of Prometheus is a bit lagging behind compared to other more advanced tools like Kubernetes. The second tool that we looked at was InfluxDB, which seemed to be a little bit more adapted to what we wanted to do, because there's really only one instance to manage in this particular case, and it was a bit easier for us to operate. And finally, there is the built-in CloudWatch service into AWS. So this is the least flexible compared to the other two. However, it was the simplest to operate, and it also allowed us some pretty advanced observability into containers using container insights. Then regarding the logging tool, we also considered, once again, CloudWatch logs. They came at no operations overheads because it was easily integratable into other AWS services. And it's also easily accessible through Grafana and Grafana Explore. So this is what we were talking about earlier by giving easy access to the developers. It was pretty much that easy using CloudWatch and Explore. And then we also looked at Loki. Loki is actually very, very easy to operate. If you didn't give it a shot, you should, because you can do it just like by running a single container using S3 at least to get started. And it turns out we were also deploying Loki in a centralized manner to have a central way where we can put our CloudFront logs across many subscriptions. So it felt natural to also plug the e-commerce subscription in there. So at the end, we went with CloudWatch and Container Insights for everything related to monitoring and some of the logging, and also Loki, and everything else just is centralized into Grafana at the end. So let's have a look at the CloudWatch and Grafana monitoring into a little bit more detail. So first of all, this is really classic. The CloudWatch data source is pretty much your first citizen into Grafana. You can add it very easily and very quickly. It's also very powerful. We use it pretty much to monitor all of the ECS clusters, the services that run on those clusters, the containers themselves, and everything related to the managed services like RDS and EFS and Elastic Cache. This is one example of one of the many dashboards that we have. So as you can see, we have an overview of what's going on the database side, what's going on with the CPU, and if there are any latencies, read-write latencies, what's the number of DB connections that we have. You can see there in the blue square, there is a little bit burst into number of connections at some point. And then if we have any deadlocks going on, we can see it pretty much instantly here. And you can see also we monitor Redis and EFS as well on the same dashboard to have this global overview. Another very useful dashboard that we made is to have a look in depth into the ECS cluster. So for example, here you can see that the first thing that we can do is to choose which region we want to look at and for which environment. And then you can see here that we have an overview of what's the CPU reservations that we have. So the CPU reservations is what you can use inside the cluster. And then there is also the CPU utilization, which is what you are actually using inside this cluster. You can also have an overview of the number of instances and services that are running. And then there is a deeper dive into the containers and tasks that are deployed. So here we have the number of services that are running, or tasks rather, that are running. And if at some point we have some of the tasks that are failing, the color just changes to red because it would have fallen under some thresholds that we define. So it's very easy to pinpoint any issues at any time. And finally, we have an overview of the pending tasks that I was explaining earlier. So this should be at 0 as it is, as you can see it on this dashboard here, which would mean that everything is running correctly. But if at some point one of these gauges goes up and reaches 1 or 2 or more, it means that either there is a deployment and it's okay, because at some point you would have anyway some pending tasks. But if this pending task stays for a long time, that would mean that either we have reached some CPU reservation level and we were not able to deploy anymore, or there is some kind of an issue that we need to look at on the deployment itself. So now I will pass it on to Laurent so he can talk to you about how we leverage Loki to have a clear real-time overview of our logging.
Thank you, Hakim. Let's now look at how we send CloudFront logs in real time to Loki. But in order to be efficient and diagnose problems quickly, we need to access logs. And as we've seen previously with Hakim, our users are all going through CloudFront, which is the CDN used as the front door for our e-commerce stack. So CloudFront is important for us because all the traffic goes through it. If you're familiar with CloudFront, you probably know that logs can be sent to S3. This feature has been there for years, but it's not real time and not that straightforward to analyze. But the good news is that since August 2020, CloudFront allows to stream the logs real time into Amazon Kinesis. And this is the feature we are going to take advantage of. But the question we need to answer is how to connect Kinesis to Loki. Unfortunately, there's no native connector to achieve that. So what we decided to do is to set up a component that would sit between Kinesis and Loki. And what this component does is simple. Since Kinesis is capable of streaming its data to any HTTP endpoints in a specific format, we have set up such endpoints to receive the traffic. We then transform the payload, which is Kinesis specific, into a payload that Loki will accept. And after that transformation, we call the Loki API to feed Loki with logs. So nothing rocket science, really. And we've made it a Docker container so that it can be executed and scaled easily. The source code of all that is available in our GitHub repo if you want to. So here is the overall architecture to send CloudFront logs to Loki, starting from CloudFront, then to Kinesis, then received and transformed by our custom components, and finally sent to Loki. And we're indeed using Grafana to explore Loki's log. And here are a few examples. So the first one, we discovered that we had an important number of CloudFront errors. And thanks to the details provided by the logs, we quickly identified what was causing the issue and were capable to fix it. Another example was a request we got from the security team who wanted to have details about SSL protocol and Cypher used on the e-commerce sites. With a single click in Grafana, we got the information and adjusted the CloudFront config accordingly. Another thing we do with Loki is around container and application logs. So what we want to achieve looks like this. We just want to send the container logs down to Loki. So to achieve that, we're simply going to use AWS Firelance that has been released in November 2019. So AWS Firelance is a log router working with FluentD and FluentBit. And the good news is that Grafana provides a client for FluentBit, and we're simply going to take advantage of it. So here is our basic configuration. On the left part, you can see that we are using the Grafana's FluentBit Docker image. And on the right part, you can see the log configuration. So there is a great detailed blog post from Cyril Tovna that you can access if you want to have further details about such setup. And as a result, our developers can easily access application logs from Grafana. If there's any problem on dev, staging, or production environments, we can right away give them access to the logs so that they can identify the issue. And no need for them to request logs extraction. It's completely self-service. So in conclusion, from a business perspective, Grafana and Loki have been helpful in having identical stacks, making it easier to maintain, a scalable infrastructure to support business growth, and geo-expandable design in any region of the world, including China mainland, and stores that can be deployed in minutes. From a technical perspective, it's a central place to monitor our stack with completely harmonized metrics across all sites, data accessible to anyone in the company, and it helps in troubleshooting faster. So thank you, everyone. We've included links to some Grafana dashboards that we made available, also our GitHub repo and our Medium publication. And if you have any question, see you guys in the chats.
Hello, everybody. My name's Jodie Barnsley, and I am currently a software developer for a healthcare company called AirLogic. Last year, I finished my degree. It was a master's degree in maths and computer science, where I studied at Leeds Beckett University in the UK. I graduated with a distinction, and this talk is going to be following my dissertation project for that degree. A little bit more about me is during my second year of that uni degree, I took a part-time job at a web hosting company and worked there until the end of my degree. Worked full-time there for a little bit longer and then moved to my current position. I like cats and plants and sitcoms, and I love getting involved in tech events like this one. I'm not on any social media, but my email address and my LinkedIn are at the end of the presentation if anybody wants to contact me. I couldn't have survived this past year without lots of people in my life. There are too many for me to single out one person. And so I'd like to take this minute to just say thank you to everyone that helped me over the past 18 months, whether that was people helping me finish my dissertation remotely, or to the friends and family members that checked in with messages and FaceTimes. It really meant a lot, your support, so thank you. But on with my talk. This is the agenda. I've already introduced myself. I will start the talk by then introducing my dissertation project, how I use Grafana, and I'll show you some of my dashboards, and then we'll be closing with some accidental COVID graphs that I made. So my talk title is Predicting Air Quality and Pollution with Grafana. This wasn't my dissertation title. That took a lot longer to decide upon than the talk title for this. I had just wanted to do something positive for people with my project. Just wanted to make an impact, just something good, something useful. After months and months of deliberation and looking at work I had previously done, it was agreed that we needed to focus on a healthcare project, maybe something that involved Internet of Things or some green technologies. And we eventually settled on predictive modeling for air quality in an attempt to help those vulnerable to air pollution. This talk title, like I say, took a long time to come up with, but it needed some rationale. And so my first port of call was finding some, which leads me to this beautiful quote from a charity in the UK called Asthma UK, which states, "We are calling for more tech development that includes easy access to alerts on air quality to help people with asthma protect themselves." So this pretty much described exactly what my project would grow to become. It also laid perfect foundations for an in-depth literature review, for very detailed thought-out methodology, and yeah, paved the way for the rest of the project. So with this, our main aim became formalized as to provide sufferers of lung-related illnesses with real-time data and future predictions for air pollution and quality in their location. This was to be achieved in the aim of forecasting air quality by using historical data to build a predictive model. So not just displaying raw real-time data, but also some future predictions to help people plan around their illnesses. This led on to 6 aims. The first being a literature review, research and planning, which I already have touched upon. The second being selecting a data source, which ended up being the UK DEFRA air quality sensor network. Aim 3 was data collection and management. So how we were going to get the data from those sensors regularly and ready to be processed and analysed. Aim 4, analysing the historical data, doing some statistical analysis on the data in order to fulfill Aim 5, creating a predictive model in order to fulfill aim 6, which was building the proof of concept web and mobile apps, but also then integrating the real-time and predicted data for end user consumption. And so with the aims and objectives solidified, I was well on my way into my dissertation. This is a project timeline that sort of summarizes how that year went. Like I say, we started with the rationale and the title, moving through to literature review and further research, which produced an in-depth methodology where the decisions to what software were going to be used were made. And once all that research and planning section was done, we got to get some data. We got to write some Python scripts to cleanse the data, manage it. We set up the database, fed the data into it, fed the data then into Grafana, built the dashboards, and moved on to our analysis. Our analysis was broken down into 3 levels. Level 1, descriptive statistical analysis. So looking at some simple graphical representations, looking for basic features, basic descriptions of what the data showed. Level 2, looking at a smaller sample of that data, often known as inferential statistical analysis, trying to determine if the data is valid for making predictions from. Leading on to level 3, statistical modeling or advanced data analysis. For the purposes of this project, this was broken down into supervised and unsupervised machine learning. Supervised machine learning being one where I provide the function with some example trends and seasonality, and then some predictions are made, and unsupervised being minimal human intervention where the machine auto detects all of the trends. Once that was completed and we had our predictions, it was time to build and polish up our proof of concept web mobile app and put in the data from our Grafana into a consumable way for the end user to access it. We then analyzed the predicted data. So the time went by, the real time went by, and we got to compare the predictions to the data that came in, but you'll get to see that later. Finally, then fully tying up, sending the data to the app in a way that aligned with the NHS's air quality guidance and sort of health alignment, so that any data that we provided and any recommendations that were made by our system completely matched up with the NHS's, because we're based in England. And finally, finishing the write-up. So the sites that we used, we had to limit them. The sensor network in the UK is far and vast. There are many sensors. For the purposes of this project, I only had a year, and so we limited them to 2 very nearby sites to my personal location. We had site 1, which is based in a city centre, where, as you can see by the photos maybe, it's 30 metres away from busy roads, 150 metres away from urban motorways, subject to congestion during peak times, and generally in quite a busy urban setting. Site 2, slightly further away from the city centre, where its inhabited, its surrounding area is commercial and some residential properties, subject to some congestion from urban traffic. These sites are only 1.8 miles apart. These maps here hopefully show you that they are not maybe going to be subject to much difference between the data collected from the sites, but maybe some difference enough due to the areas that surround them. So onto my dashboards, where everything starts to get a bit exciting. This was my key dashboard, where you can see we've got site 1 on one side, site 2 on another. The top panels show the daily mean of the 5 pollutants that are collected by the sensors. The bottom panels show the hourly data, and the panels in the middle show the current or the most recent data for PM10, PM2.5, and NO2 for each site respectively. This fulfilled the definition of level 1, just some basic graphical representations of the data so that we could perform some just easy visual analysis. This is our level 2 statistical analysis. This is focusing here on PM10 only. You can see site 1 is in the yellow and site 2 is in the green. These are the daily mean of the PM10 pollution rates for each of these sites using the Grafana time regions feature. The days of the week have been color coded and the weekends have been grouped together. Initially, this showed not very much trend between the days and days, between Monday data to Monday data, Tuesday to Tuesday. However, we were able to determine that there were noticeable dips on weekends. Not all weekends fit into this category, and this is a small sample of the full level 2 statistical analysis that was conducted. But overall, we were able to determine that there was seasonality present in this particular pollutant to perform level 3 statistical analysis. And so here is the supervised machine learning prediction graph. You can see we've got daily, hourly, real data, and then we've got the blue line, which indicates the predicted data. This used the influx Holt-Winters feature, which again is plotted on the Grafana dashboard here. This uses the daily average along with seasonality mappings to produce a daily forecast. You can also see here we've marked on the weekends in blue again, and we've also got some horizontal bands, but I'll come to those later. Here is the table that shows our results. We've got the Holt-Winters predictions that we just saw plotted. We also have the Excel predictions. This is the unsupervised machine learning, where Excel's forecasting built-in tool was just given the same data sample used to base the Holt-Winters prediction off. And we also have here our actual daily mean for this predicted week. We were able to conclude that the supervised, the Holt-Winters prediction was significantly more reliable than the unsupervised. Here is a closer up look at that data, the real data alongside the predicted data. And so here I will explain the horizontal divisions. We have our green line, which represents 50 micrograms per meter cubed of PM10. This is what is determined as a safe air quality for this pollutant. The next section up to the amber line would be medium, up to the red would be high, and then above the blue line would be very high. And so what's important to realize about this predicted data that was created is that whilst the daily prediction may not completely align with the hourly data, it is, whilst very close to the daily average, is also well and always in the same air quality band, and therefore the end user would be receiving the appropriate air quality band as the prediction, and therefore safely be able to plan around that given the health advice that would come with it. Moving on, here you can see how that data was used in the proof of concept mobile app. It's very bare bones, and the web app looked very similar. You can see that we've got the sites marked on here with the pins. We also have the interactive speech bubble that displays the average and the predicted data. And we also have the pins on the left image showing the bands, the band colors as well. So that was my dissertation done. That was my degree done. I received my award, but I haven't yet had a chance to actually go to a graduation because of COVID. And the months went on. I left my job at the web hosting company and moved on, not really thinking much about my Grafana instance or all of the systems that I'd had set up until a couple of months later. I just happened to go back and find that I had accidentally made some COVID graphs. I know it's not perfect project management, not closing everything down, but I wouldn't have these without it. So there we go. This dashboard here is the key dashboard that I started with earlier on. I have marked on here using the annotation in blue, the first UK lockdown. Again, in the top, we've got daily mean, and in the bottom, we've got hourly mean, and we've got them split by site. You can see here already that there's a noticeable drop in all of the pollutants during the lockdown. The roads were very, very quiet, and I think it's safe to say here that it definitely had an impact. You can see on the right-hand panels, there's these two sections here, which shows the same time period in the year prior to that as being significantly higher, again, across all pollutants, but we can take a closer look. So looking at the city centre sensor, which was the one surrounded by the busy roads, this little excerpt here from a dashboard shows NO and NO2. The main consumption of NOx, including NO and NO2, is fuel consumption. Therefore, less cars theoretically would mean less NO in the atmosphere. And it did. We can see again from the annotated lockdown period that the pollutant levels were significantly lower after the lockdown had been enforced. We can also see here where we compare the lockdown periods in 2019 and 2020 for the Headingley sensor site, that pollutants generally across the board are all lower. And we can look at the winter period here in 2019 to early 2020 and October 2020 to January 2021. We can see that whilst we were not in lockdown completely during that time, we were still under some restrictions, and that also managed to have an impact on the pollutants. Here we can see the most recent data. So we've got April 2019 to June 2019. We've got it in 2020, and we've got our April data for 2021. We can see instantly that during the lockdown period in the middle, the nitrous oxide in the atmosphere was significantly lower than the previous year. And we can see that now we are coming out of lockdown, it is already starting to rise, showing clearly that the impacts of the lockdowns and how they have affected cities in the UK and undoubtedly around the world. To summarize, Grafana has done a lot for me over the past couple of years, from winning me my degree to accidentally recording all of this crazy stuff about air quality during a pandemic. So thank you for that, and thank you all for listening. My email address and LinkedIn is there if anybody wants to contact me. Thank you very much.
Hello, I'm Dave Schmidt, a senior solutions engineer here at Grafana Labs, and welcome to my GrafanaCon lightning talk on variables, links, and overrides. I couldn't have survived this past year without two significant parts of my life. First, my girlfriend Lisa and her ever optimism and encouragement to take on new challenges. And secondly, as a musician, the opportunity to really immerse myself in creating new music. Today, I'll be showing you how I personally use some of my favorite variables, links, and overrides to build out a fun set of dashboards based on my custom WeatherFlow weather systems data collector. To start out, variables. A variable is a placeholder for a value. You can use variables in metric queries and in panel titles. So when you change the value using the dropdown at the top of the dashboard, your panel's metric queries will change to reflect the new value. My first variable here allows me to present a set of days as part of a future 10-day weather forecast. I want to always have today's date, but my underlying data includes all of the days that I've ever measured. Each day has a single measurement with a timestamp at midnight. So using this $time filter query provides just today's data, and in this case, 24 in the following 10 days, as I've only included now and now plus 10 days in my time range controls. Another favorite variable isn't really a query at all, but a static list of time spans that will be used in the query options min interval section, which then populates the interval option as well. Now, normally interval is an automatic interval calculated based on the width of the graph. This changes though based on zoom levels, time spans, and scrape intervals. I use this kind of interval variable as a way of letting users change the smoothing levels of the data to their own preferences. Here's an example between coarse grain and then blending into fine grain data aggregation for different temperature metrics. Next up, links. Dashboard links help users navigate between commonly used dashboards or to connect others to the visualizations. Shortcuts can be other dashboards or panels or even external websites. In this first example, this dashboard link provides a dropdown that shows all dashboards that match the WeatherFlow collector tag. There are options to automatically include time ranges and template variable values so that users can carry across the data context from one dashboard to another. You can also choose to open links in a new tab or not. This second example shows an external website link rather than a dashboard. In this last example, the actual dropdown of all available WeatherFlow collector dashboards and an easy way to visit my website. Third, overrides. I look at field overrides as a way to provide unique differences to each of my field measurements. Everything that's available to a normal field option can be overridden for a specific field. Think of this as having a default setting for all your panel fields, and then an override for just the fields that you want to be different. This can be helpful for table visualizations, but also helps really set multiple queries apart when using time series visualizations. My first example here is helping set colors, and line widths, and opacity styles for a time series panel for fields with specific names. I've then used additional overrides to provide specific thresholds and color gradients for a measurement of station pressure. I've also changed the unit to inches of mercury and a minimum of 3 decimal places. And here's an example of 4 different metrics for high, low, and feels like high and low, with different line styles and dash patterns, different line widths, opacity types and levels, and point size. It's also good for hover size if it's actually hidden. And finally, the ability to change a table cell display mode to image, and use value mappings to turn a string field into transparent weather icons. And finally, bringing them all together. In my way of bringing all these variables, links, and overrides together, I'm using data links to provide a way to change the filtering and visualization of my data. Anthony Woods put together a great lightning talk about data links, so I'm not going to go into great detail here. But my override does let me do 2 things. 1, set a custom time unit for my date field, and 2, create a clickable link back to that same dashboard, but changing 4 behaviors using hidden table fields and reusable template variables that are both visible and hidden. Together, that lets me filter a query to a specific forecast day tag, updates my interval from 12 hours down to 1 hour, provides a panel title change, and changes the relative time range selection to a future 24-hour period. Now, in action, it looks something like this. Here's my 10-day weather flow forecast dashboard. Daily forecasts are on the left-hand side with pre-selected current hourly segments on the right. Below that are 10-day overviews with highs and lows depicted by the 12-hour interval selection at the top. Now, when I click on a specific day on the left-hand side, for this example, I'm going to choose May 27th. Several things happen with the use of those variables. I went from now plus 10 days as a default time range to now plus 3 days over 3 days, which is essentially May 27th, 3 days into the future, but with 24 segments of time. My panel title for the hourly segments has changed to include now my custom date format override. And my forecast day moves to the 27th, with my smoothing interval moving to 1 hour. And finally, what was once a 10-day, very smooth-looking overview of precipitation now shows a more precise hour-by-hour accumulation. My weather flow collector project is a fun effort that helps me explore how Grafana provides for creative and easy ways to visualize weather conditions hyperlocal to my backyard. Here's a dashboard showing real-time precipitation accumulation and lightning strike counts paired with distances. And finally, a dashboard showing a collection of forecasts versus actuals for temperature, humidity, wind, pressure, and UV. Thank you for allowing me to share with you how I brought together some of my favorite variables, links, and overrides. Please be sure to share with us your own dashboard creations.
Hi, my name is Anthony Woods. I'm one of the co-founders and the CTO here at Grafana Labs. Today, I'm quickly going to speak with you about data links, a powerful feature of Grafana that allows you to place contextual links within your dashboards. Today in Grafana, there's 3 types of links that are supported. We have dashboard links, which are available and displayed at the top of a dashboard. We have panel links, which are accessible by clicking on an icon on the top left corner of the panel. And we have data links, which allow you to provide links based on the data being shown inside the panel. So you can create links that include the time series name or even the value and timestamp of an individual point. With data links, you can easily guide users to additional information based on what they're seeing in the dashboard. Links could lead users to external systems and services, or it could provide drill down links to other Grafana dashboards. The links themselves are accessible in different ways depending on the visualization type being used. So for the graph and time series panels, you would need to click on an individual data point or line to bring up the context menu with the links. For a panel like the stat, gauge, bar gauge, or pie chart panels, you can click anywhere on the visualization to open the context menu with the links. And for table panels, the links are available when clicking on any cell within a row, or with field overrides, you can configure different links for each individual cell. So how do we do that? Let me show you. So here I have a table panel, and this is loading some Kubernetes event data that we store in our Loki logging system. So for each of these events, I've got the cluster name, the namespace, the workload type and name, and the action that was taken, such as updated or created. And so every change inside the Kubernetes cluster is logging one of these events. And this is a great starting point for users when they see issues on a cluster, where they can quickly jump in and have a look at the most recent changes that have happened inside the cluster as a starting point to start looking for issues. And so for each of these, I want to be able to link users to a detailed dashboard that will give them some summary metrics about each of these workloads. And so to do that, I'm going to create a data link. And so you'll see here the data links available in the right-hand navigation menu. And so I just click add link and give it a name, workload details, and I'll put in a URL. And so the URL I'm using here is a link to an existing dashboard that I have in my Grafana instance. And when loading that dashboard, I'm passing through some query parameters that will be used to set template variables within the dashboard, such as cluster, namespace, type, and workload. And so the format for the query parameters is var dash and then the template variable name. And for populating the values of each of these, I'm loading data that's being shown within the table panel. So for a list of available variables that you can use within your URL, you can press Control Space, which will, or Command Space if you're a Mac, which will give you a list of all of the available variables that you can use to load. And so in addition to the cluster namespace and workload, I've also used the time range variable, which will add the query range that's currently being shown for this dashboard and ensure that the destination dashboard also uses the same time range. Optionally, you can also select if you want to have the links open in a new tab or not. All right, so we click there, click Save. And so now we'll see that each of the cells is now clickable, and it will tell us that we can navigate to our workload details dashboard. When this loads, it's going to pre-populate all of our template variables with all the values that we want to have set. And this dashboard now also has some drill down links, so we can use this to click and drill down even further into additional dashboards with the more detailed view of what's happening in our environment. Now let's say that we wanted to show a different dashboard, perhaps a namespace summary dashboard to give a higher level of details if user clicks on the namespace name. And so to do that, we can use a field override. So here I want to add an override for a field with the name namespace. And the override I want to use is to change the data link. And again, give it a name, so namespace details and a URL. And so in this case, I'm linking to a different dashboard and I'm just passing through the cluster and namespace names. And then we can also pass in our time range value as well. There we go. Click Save. We'll open this one in the same window. So now we'll see here, if we click on the name here, we'll go to our workload details. But if we click on the namespace, it's going to take us to a different dashboard and take us to a namespace dashboard. And there we go. All right. And that's it. Thanks for your time. And now I'll pass you on to the next lightning talk.
Hi, everyone. I'm Anna. I'm a senior UX designer working for Grafana Cloud. Today, we'll be discussing quite a disregarded topic when it comes to software, and that is accessibility. We'll have a quick chat on how you can improve your dashboard's accessibility, plus what our plans at Grafana to improve the overall accessibility for our products. But first, let's understand together what accessibility means and why you should care. So first, when we discuss about computer accessibility, we refer to the accessibility of a computer system to all people, regardless of disability type or severity of impairment. So it's considered that 1 billion people, or 15% of the world population, experiences some form of disability currently. It can be vision, mobility, cognitive, even psychological. Most of us immediately think of colorblind people or even completely blind people, but we so much disregard that people can suffer from maybe an accident and they will be momentarily disabled, or that some of us will maybe carry a child in our arms. So for a given period of time, while you work, you won't be able to use your mouse. That is even more true today, when everybody kind of works from home and we have kids playing around. So what can you do? I mentioned we'll be discussing about dashboard accessibility. How can you improve in a few easy steps? Start with color and fill. You can, by using the panel edits and series overrides, you can pick contrasting colors and in general try to avoid using red and green in the same chart. Also increase the line widths and use solid fills instead of gradients. Right? The other thing you can do, you can display the legend that should also include min, max, and current values, so that will be interpreted better by screen readers. You can also limit the number of panels per dashboard and avoid using too many columns of panels per row, because if you do so, information will be a bit too crammed and it will be quite hard to understand what's on a given chart, for example. And let's have a quick example. On the left-hand side, we have a chart that is red and green. And while some of you might see it, I'm sure there are users and people in this talk that will have a hard time understanding and distinguishing between those values. So it's not so colorblind friendly. On the right-hand side, on the other hand, I have switched from red to green to blue to green. And I've increased the line width, plus I'm displaying a legend that has more values. In this case, mean, max, current, but you can also, for example, show the average or whatever you need by using the same overrides. So a screen reader will be able to read that legend table values. On the other hand, we do know that it shouldn't only be on new to improve accessibility, and that panel edits like this are just a small part overall. So we have assessed where we are today, and of course, there are a lot of things to improve, but we do have a plan, and we have a plan to work hard this year to follow and reach the international standard for accessible software. For those of you interested, that is called WCAG 2.1 AA. So what it actually means, but of course it's not limited to, we want to improve the contrast for the current themes. We already have launched new and updated themes with Grafana 8.0, but we will still keep working on them. We want to create a high contrast light theme as well. We want to make Grafana interface accessible via keyboard only. And with that, you'll also be able to use screen readers far easier than you can do today. Create a colorblind friendly palette for data visualization panels. So an override will be so much easier to do by using an already tested color friendly palette. And also provide an alternative to graphs that can be interpreted by screen readers. You'll see that we have a switch available now to show the data as a table, the data behind the panel. So we'll continue to work on this type of improvements. And please feel free to add new ideas if you have, or bring new issues out. You can do so on our community, either on Slack or on our community forum, by opening a GitHub issue. We have an accessibility label and a template for that. Thank you for watching.
Hello everyone, and welcome to GrafanaCONline 2021, where we're going to talk about transformations. Good morning, good afternoon, good evening to you, wherever you're at in the world. I hope you're having a great day so far. I love the fact that we're fully distributed as a company and we get to talk to people from all over. It's one of my favorite parts about Grafana. My name is John O'Brien. I'm one of the senior solutions engineer here at Grafana, which means I get to talk to people every day about how they're using it, what they can possibly do with Grafana, and without fail, one thing that always comes up when we're talking about what Grafana can do for people is transformations. And that's what we're going to talk about today. So let's get right into it. For a quick overview of what we're going to look at, we're going to look at transformations and why they matter. We're going to look at different types of transformations that we have out there. And then I've got a few examples of some transformations that we've used to build out a few different dashboards in our demo environment that we use as solutions engineers. So, transformations and why they matter. These were introduced about a year ago in Grafana 7, and ever since then, they've become a very kind of popular choice, or actually fairly secret weapon for those that are using Grafana as to the ability for them to be able to manipulate their data however they need. Because what happens is you can actually manipulate and change your data at the browser dashboard level with transformations. And you do this by processing the result set of a query before it's being passed on to your browser for visualization, which is really great because if you think about it, a lot of times you would actually need to go to the source of your data to be able to get it to display the way you wanted it to before you actually visualized it, and you would just visualize that result. Grafana says, give me the raw data and whatever your form is, and we can manipulate it and kind of mold and shape it into what you actually want to be able to see. So you can do this in multiple different ways, and you can do this across multiple different data sources. And what I mean by that is, like, let's say you have 2 different or 3 different Prometheus instances, and you want to compare metrics across the 3 of them and do some math or some operations across them. You can do that. Or for like the example that I'm going to give here in just a moment, you can actually take transformations and do this across like multiple different logging sources and show information from multiple different ones combined into one singular, particular metric, if you will, bit of information. So yeah, transformations, they're really cool. They allow you to join multiple different time series together, do math across multiple different queries, you can hide and you can organize fields and more. And can probably talk about, now it's probably time to talk about the different kinds of transformations that we have as well. We have things like reduce, merge, filter data by name or by query. We can organize these fields, and we can join the fields using outer joins. We can do addition of fields from calculations, or we can filter by value. We can take labels to fields by field name or merging behavior. We can sort and group by. We can concatenate fields. We can take series to rows, and we can rename by regex. Don't just take my word for it. I wanted to read out all the different ones we have because I really wanted to show that how deep the possibilities are for you to actually be able to transform your data however you need to do it. But if you look below, I've included a link. I know you can't click it on video, but feel free to type this in, look for our docs, or even just Google like Grafana transformations, and it'll take you to this page in our docs to talk about how each of these work with some examples from all of them as well. But if we're going to talk examples, I should probably talk about an example that we use inside of our solutions engineering team. This is a dashboard that we call Elastisblog, but essentially what we're doing is we're taking logs from 3 different sources. We've got our logging tool Loki, we've got Elasticsearch, and we've got Splunk. This is a screenshot, you can't see Splunk, but if you scroll down, it's at the bottom of this particular dashboard. And they're all showing the same information. You can see we have our info, warn, and error. We have a graph of how many logs are compared to, like, how many of each of those types of errors there are compared to the total error count. You can even see the raw logs here on the right side, pulling that in there. And you can think of maybe an example of this would be maybe 3 different production environments that are using different tools, or 3 different environments where you're testing things out and you're saying, all right, we've got dev, stage, and prod. We're going to use these logging tools for each of these, whatever it might be. And this could be any different data source. I'm just using this for our example. But you're like, all right, John, I want to kind of take all of these different data sources and I want to combine them into one to see the total logs, the total errors, the total warns, and the total info logs inside of each of these sources. You can see that up at the top of this, where we've combined it all. So how did we get there? Well, if you haven't figured it out yet, we are going to talk about transformations, and we are going to use transformations to do this. So this is what this data and what these queries look like without transformations. It's pretty raw. It's a table. You can see we've got our Splunk query down there at the bottom. We have Loki, we have Elastic, all pulling in timestamps and the different errors that are coming in. Frankly, this data right here, this particular table, is not very visually appealing, and it's not very useful on top of that, which I would say is the more important thing. How do we make this useful data? Well, this is where we have our transformations, where we concatenated our fields, and then we organized them by using error, info, and warn based on basically the types of errors that we wanted to see. And then we reduced them, taking from series to row based on our total calculation. And then we grouped by field and the calculative total again. And then we did another thing of organizing those final results by sum in our logging level. And as a pro tip, I want to shout out, because exactly what I just showed is something that's we use as the order of operations. So just like in math or in development world in general, the order of operations matters. So because we're processing these results in a browser, you take your set of data, you manipulate it with transformations, and then it becomes a new result. And then you can take that result and transform that, and so on and so forth. So you can actually, in the Grafana UI, take these and move them around as needed to achieve your desired state, just knowing they're going to be applied in whatever sequence that you've listed. So in summary, what we've done is we've taken the kind of bland, vanilla, not helpful data here on the left. And then on the right side, we've actually taken our transformations. We've used 5 total. And now we're able to see in a kind of a little bit prettier and easier on the eyes way how many different error, warn, and info logs that we have across our multiple different data sources, all achieved by using transforms. So thanks for watching. Again, my name is John. Super appreciate you hanging out, joining us for GrafanaCONline. Make sure you check out some of the other sessions, and we'll see and talk to you soon.
Howdy, everybody. Hope you've been enjoying the lightning talk so far. I'm Alex Martin, Director of Professional Services here at Grafana Labs, and I've got a lot to talk about in a very little amount of time, so let's get started. So let's talk about Tanka and how you can use it to manage everything about Grafana. I do want to preface that there is work going on in the background to make what I'm about to show you less tool dependent and more streamlined across the entire Mixin's ecosystem. But all the ideas you'll be learning here will be sticking around. So what is Tanka? Tanka is our take on how you should be managing your Kubernetes cluster using the JSONet language. Unfortunately, I can't give you much of a primer on Tanka or JSONet, but the Tanka website has an excellent getting started guide if you want to check it out. Now, why would you use Tanka with Grafana? Not only does it help you manage your Kubernetes deployments, but it also manages the configuration of Grafana itself, including the dashboards, plugins, data sources, and more. So let me pull up my terminal to show you what's going on. So on the right side here, I've got the main JSONet file that is configuring our Grafana Kubernetes cluster. And hopefully you can see it's quite readable. We were pulling in the Grafana JSONet library from GitHub. This is built into the repos, so that's why it's been pulled in relatively. And then we've got some local dashboards, data sources, and mix-in libraries that I'll show you in just a second. So right here is how Tanka knows that, hey, we want a Grafana cluster. You could run this configuration with just that and delete everything else. And that would basically spin up a completely empty vanilla Grafana. But that's no fun, so I've customized our deployment a bit. This whole GrafanaCon is centered around Grafana 8, so let's pull that version in. Now let's set our root URL, and we're not monsters, so we're going to use the dark theme. And since this is an example, I don't really care about logging in, so let's allow anonymous sessions. Before I get into the rest of the configuration, let's actually deploy this. So on the top left, I've got my Kubernetes pods being watched, and there's nothing in this namespace right now. So then if I do a tk apply onto the cluster, you'll see in a second that Tanka will spit out a diff of what it's trying to deploy, of the exact Kubernetes manifest that's trying to deploy. And you know, it's going to be all green because it's all going to be net new because nothing is there right now. And I'm going to assume this is all working and then create my cluster. So you can see that it's gone and created all these resources, and you can see that the pods, a single pod has indeed been started and it's running Grafana. So now if I quickly port forward this pod and then open up Chrome and then go to localhost, you can see I've got my dark theme anonymous session Grafana instance up and running. So let's say deployment wise, real quick, I wanted to have 3 replicas because I know I'm going to have a lot of people using Grafana and I just need more than one. So if I go and say with replicas 3 here, and then I redeploy my config with tk apply, we should get another diff that says, hey, I see that you don't want 1 replica, you actually want 3, which is what we want. So I'm going to say yes, and now you can see that's applied the changes, and we do have 3 pods of Grafana running now. So now let's jump back into the config. So with this one line, I'm able to go and pull in the sun and moon data source, which will help me fetch some telemetry on the sun and moon, as you could probably guess. Next thing I need to do is actually set up some data sources so that we can actually get some data going. So we're pulling in a Prometheus and this New York City data source, and let's look into this data sources file that I'm importing. So if I exit out of this file and then I look at the data sources.libs on it, you can see that I am pulling in configuration on Prometheus and sun and moon. So with the Prometheus data source, I'm giving it a name. I'm giving it the URL for where the Prometheus server actually lives, which happens to be another Kubernetes deployment on a different namespace in this cluster. And then I want Grafana to understand, hey, this is a Prometheus type of data source. And then last but not least, I am actually sending it as the default data source. That's what this true does. And the final pro tip, which you should be doing if you haven't been, you should always set the Prometheus data source to have to use the post HTTP method. It'll give you much better performance. So if I go into Grafana and I look at my data sources, you can see I have the Prometheus data source. It is set to default. It is using the URL that I want, and it's using that post method. And then lastly, you can see that there's this banner that says it's a provisioned data source. That means that Grafana understands that this was generated by some kind of config and not put together through the UI, meaning it doesn't allow people to go in and manually override these settings. It's a great way to be able to lock down your data sources and ensure that no one is accidentally fiddling around with them. So for the second data source, it's a little less traditional. It's definitely not a Prometheus data source. So I'm calling it New York City for reasons you'll see in a little bit. It doesn't take a URL, so I can leave that null. And the type of data source that Grafana is expecting is the same as the plugin ID. So it's this Sun and Moon data source plugin ID. And then what this data source actually needs to run is coordinates to actually compare the metrics of the sun and moon to that coordinate. So it needs a latitude and longitude, which in this case happens to be the coordinates on Manhattan. And that's why I've called this NYC, this data source NYC. So let's go into Grafana again. Let's look at our data sources and let's go to this sun and moon data source. And you can see it has been added. It has the longitude and latitude that we're expecting, and as well as the name. And you can see Grafana has, it understands that this is a provisioned data source that cannot be modified. Awesome. Hope you're all still with me so far. So now that we have our data sources, we need some dashboards to actually visualize the data that they're holding. So let's go back into main.jsonet, and you can see that we're pulling in two dashboards. I'm relying on this local file called dashboards.libsonet, which I'm going to take a look at right now. Oops, not this one. And it's just tidily pulling in the actual definitions for the dashboards. And so this one, I'm sure everyone will know, is the node exporter full dashboard. So it's the one which I'll show you real quick that it has been deployed. If I go into my dashboards and go into node exporter and go to node exporter full, it's the super dense node exporter dashboard that everyone knows and loves. So you can see it's all been set up correctly, and as you probably all remember it. The second dashboard for the New York City sun and moon data source is a dashboard that I actually made in Grafana and then just exported the JSON. So I just went ahead and copied the JSON into this dashboards folder, and this looks like your typical Grafana dashboard JSON. And then that's being pulled in and loaded through here. So if I go into the dashboards and then I take a peek at the New York City dashboard, you can see I can now look at the altitude of the sun and the moon and the sky from the Manhattan skyline. And yeah, so that's one way that you can actually keep your dashboard JSON in version control and deploy it this way. So we've got the dashboards now, and they're all working. The last thing I want to talk about is mixins. So a lot of communities have created alerting and dashboarding mixins for their exporters, and now you can actually use these dashboards directly in your Tanka config. So if I open up main.jsonet, you can see I'm pulling in some mixin dashboards, which are being declared in this mixins libsonet file. So if I open up mixins.libsonet, you can see I've configured the node exporter mixin for use for the dashboards. So the configuration you can see is I'm putting it in a folder called node exporter mixin. And then I am overriding the selector for all the panels. So, in Prometheus, it needs a label to be able to determine what metrics to show. And in this case, this is filtering based on that job label, and I want to make sure it's using the correct job label that I have set up with my Prometheus instance. So if I go and check Grafana, I can see that my Node Explorer mixin folders here, it's got the 3 dashboards that correspond to this mixin. And then you can see that everything is hooked up correctly. And then if I go, let's look at the memory usage, probably really simple. You can see it is populating that job label correctly. Alrighty, so that's all I can squeeze in for today, guys. There's so much more that you can do with Tempo and Grafana. There's even a whole Prometheus JSONet library that you can deploy to get Prometheus, Grafana, and the Prometheus mixins out of the box. Everything you saw today will be found in our JSONet libs repo. It's on GitHub. The library itself is found under the Grafana subfolder, and then there's the example/Tanka folder that has exactly what I just showed you today. So you can go and copy and analyze that for yourself. Again, thank you so much for attending GrafanaCon. Hello. Well, thank you so much for tuning into our lightning talks. We only have a couple minutes for Q&As, so let's jump right into it. We got a couple of accessibility questions and usability questions. So one of them, it's actually more of a comment, but I don't rely on screen readers, but I still prefer keyboard navigation as it makes me more efficient. Can't wait to see more keyboard-friendly Grafana. Oana, do you know if there's any work on adding more keyboard shortcuts?
Yeah, so that's our plan. And basically on our roadmap or wish list, because somebody asked that before, one of the most important things is to make it fully accessible by keyboard. We have already started work on that. We'll probably start with a core feature like Explore and basically the query builders and build from there. But at the end, or in a year from now, I hope you'll be able to use 100% Grafana only with your keyboard. And that will also benefit those who use a screen reader.
Excellent. So on the complete opposite side of the spectrum, are there any tips on making the dashboards more mobile friendly?
There are. While the current dashboards, if you try to make your screen smaller, they will definitely are responsive, but there is probably at least one breaking point, I don't know, in the tablet mode. So what you could do, definitely less panels per row. For example, time series or bar charts might scale well, but an alert list or a world map panel, not so much, right? An alternative would be, because you could have very complex dashboards, create an overview dashboard of those dashboards where you highlight maybe some of the data that you have in there and link the other dashboards. So if you really need to dive in, you can totally do so, but try to keep it simple for the mobile view.
Awesome. And now that we have the library panels, you can actually make maybe a mobile friendly, smaller overview board, like Oana was saying, much easier. You don't have to worry about changing everything all over the place. Alrighty, so this one is a pretty good question from Alexi. Do you have the ability to fix the order, or set manually, the items in the graph legend block? And this is definitely something I've seen where, if you have a refreshing interval, sometimes things move around in the legend. I don't know if we have a way of fixing that order or setting a specific order.
Not that I have seen, to be honest. I've seen this being a comment before, so maybe it's something we could keep in mind. I know for the colors, on the other hand, that you could indeed use overrides, and those should remain fixed, so in case something changes.
Awesome. And there is a ways to actually do the sorting on, if you're using something like PromQL, there is a sort function as well that you might be able to leverage, but it won't be able to sort the actual labels. Awesome. I have a question here that says, is it possible to share the data link Kubernetes dashboard? So there's a couple ways to interpret this. I think it could be, do we have a link to an example, data link example with Kubernetes dashboards? I think that's something we could probably post in the community Slack channel to help you out. If it's if possible, to actually use the existing Kubernetes dashboards to link out to, say, if you're looking at your pod graph and you want to link out to like the namespace for that pod, like a specific namespace dashboard or specific pod view dashboard or node dashboard, that's definitely something you can do with data links.
So I'll just add to that as well. So in the demo I gave, the dashboards I showed there come from the Kubernetes mixin. So that's an open source kind of mixin, and as kind of Alex talked about with Tanker, you can deploy that pretty easily with Tanker into your cluster. So that's available. It's also part of the Grafana Cloud integrations. There's a Kubernetes integration there that uses a slightly trimmed down version of that same mixin, where you'll get that same linking between all of the different Kubernetes dashboards. So you can start at the cluster level and drill down directly to a single pod.
Awesome. And we have time for one more question, again from Alexi. Can I transform a JSON block from Loki, the text log line, to basically a legends? So using like the host or something like that. So you don't actually have to use transformations. You can actually use a JSON formatter to actually extract those keys and turn them into labels, and then you should be able to use the label templating inside the graph panel to actually use those labels as the legend. So that's something that if you want to ask more in the community Slack channel, we can help you out there. But I think that's all the time we have. Thanks, guys. It's been a ton of fun.
Hello and welcome. This is a lean, mean monitoring machine, Grafana at every scale. I'm Andrew Burian, SRE at Dapper Labs. And with that, let's go straight into introductions. Because in case you want to use anything that I'm going to suggest in this presentation to try to argue that you should or shouldn't do any of these or some of these things yourself, I'll try to make it sound like I know what I'm talking about, and you can pretend that my points have credibility. So I've spent most of my career at this venture studio, Axiom Zen, making all sorts of products from scratch. We've built ZenHub, Toby, Routific, and probably most famously CryptoKitties, because we decided the blockchain needed more cats. From there, I've spent most of my time at Axiom Zen spinout, Dapper Labs. We're building the Flow blockchain, we're building the Dapper wallet, and again, we're probably most famously known for NBA Top Shot. I've been the head of SRE and infrastructure at pretty much all of these ventures, and at this point, I like to think I know a little bit about what makes infrastructure go round. So the question is why should you listen to me on any of this? As a company, this graph is burned into our brains because intentionally or not, we've sort of ridden this curve a number of times. This is the Gartner hype cycle, if you're familiar with it. It shows basically how visible or how much traffic your product gets sort of over time as hype increases. I'll leave speculation of where we are right now to the armchair entrepreneurs in the crowd, but we've seen this burst and we've ridden this wave a couple times, and touch wood, we've survived every time so far. Our current crazy success seems to be NBA Top Shot. If you haven't seen this before, this is our spiritual successor of CryptoKitties. It is our digital collectibles on the Flow blockchain that's officially licensed NBA products. It's a lot of fun. Go check it out. It's also been the source of a lot of crazy stress recently. So we're here again, middle of this hype cycle for NBA Top Shot, and I'll be pulling all of my examples from NBA Top Shot because this one's the freshest on my mind, which is where the scars are the most present. But when we released our beta at the start of this year, we started getting traction. We were thrilled when you start seeing that sort of slope and adoption. As a beta product, you're testing the waters, but we're clearly sort of onto something. Now, this talk is about observability, not building startups. So I'm showing this graph, which is actually our metrics ingest. It scales sublinearly with traffic for the most part, but it's a good job for this purpose for capturing sort of the load we experience on observability. So this is the 5x you hope for when you launch a beta product, great success. This is the 50x you get that you're not prepared for that sort of destroys your hopes and dreams. This was another month in after our first sort of success, and our fire turned into a pile of napalm. No time to replan, no time to re-architect. You either catch that wave and ride it or you fail. Now we're kind of humming along a few months later, kind of at that high water mark, and touch wood again, we haven't failed yet. So I'm not a big fan of surprises. I'm going to tell you exactly what I'm going to tell you this presentation. I'm going to tell you we're going to start efficient. We're going to teach you how to make some good choices up front when you have no product. You're going to grow your monitoring like a product parallel to the product you actually have. We're not going to overbuild. We're going to prepare for success. We're going to survive a massive rush, and we're going to plan to continue working well at scale going forward. This presentation, it's important to note, is largely in the form of we did this at this time, this way, so learn from us, which means by definition, this presentation is also a presentation on survivor bias. This is one of my favorite stories, but in the Second World War, the British bombers were barely armored due to their weight limitations. And so the British studied their returning bombers to decide where they should put the little bits of armor they could afford. This turned out for the British to be completely useless because the bombers that were coming back told the stories of the survivors. The ones that got shot in different places never came back, didn't get studied. So I can tell you where we put our armor plating, and I can tell you that we've survived, but I can't tell you where we didn't get shot. Read between the lines a little bit, your mileage may vary. So let's start this at the very beginning. We have a dream in our hearts and a product that only exists on our whiteboard. Where do you start? You have to start thinking about monitoring early, but how? Everyone will tell you here, and I agree, the devil's in the details. No premature optimization, no overbuilding, try to avoid unnecessary complexity. All these things slow your team down. But that said, if you're in a market that's fast and famine or boom or bust, you have to be ready to kind of catch that lightning in a bottle, and you can't afford to make mistakes at this point. They're going to slow you down and cripple you later. We have had the luxury of some experience scaling things up. We know where some of the stumbling blocks were, so we started simple. For context, we were running on a 3-node Kubernetes cluster, which I could give a whole other presentation on whether or not I would recommend starting with Kubernetes. Not necessarily a good idea for everyone. We had some experience, we knew what we were doing, it made sense for us. So we rolled out the most basic possible monitoring setup on top of that. A single 1-node Prometheus instance, 60-day retention on a single persistent disk, and wired that up to a little self-hosted Grafana instance that was plugged into our Google OAuth. It was reliable in so that it didn't go down by itself, but it went down every time you rolled the nodes, every time you changed deployment. HA like wasn't a thing. It missed some data. It wasn't performant by any stretch of the imagination, but it worked. And it took me less than a day to set up. So fragile as that was, I would not have done anything different. I don't recommend you do when you first start. You have no product. You have no money. You don't know what tomorrow looks like at all. This is at best groundwork. You're trying to get the most you can do with little. Keep vendors at arm's length for kind of as long as you can while you're still playing the waters. Don't waste your time. So obviously there's a few choices we made here that I think really paid dividends in the long term. And they come in two categories: the tools we chose and the mentality we adopted. Everyone loves tools. Let's start with tools. Prometheus, easy win. I gave an entire talk at PromCon last year called Prometheus for Agile Teams, where I talked about the reasons that Prometheus is really good for 0 to 1 work. I won't hit on that too hard right now, but the key takeaway there was that Prometheus lets you get started with very little. You sort of have that built-in dashboarding tool. It does all the scraping itself. You run it on one instance, and it scales up as far as you need to push it later. Really good choice for a tool. The next tool probably goes without saying. This is GrafanaCon, but Grafana was a really good starting choice. The open source model and relatively simple deployment meant that I had a really user-friendly dashboard solution going from day one and like an hour after we had the storage set up. Didn't cost me a dime. I could start training the engineers to do PromQL queries, which was new to some people. And as we'll go over later, it scaled. So the tools aside, the other interesting thing that I think we did was a little more subtle, was we started setting the expectation around how our monitoring platform was going to work going forward. From day one, we started training the engineers that they need to understand how to monitor as far as what to instrument and what metrics to emit. And at the same time, they don't really need to worry about what happens to the metrics from there. Just start emitting Prometheus metrics and don't get too attached to how it gets showed to you. It'll show up somewhere down the line. This is valuable because it decouples the how from the why. It lets you change your monitoring setup in the future and pivot around all the problems and things you might have. It lets you recode and retool without changing a bunch of services to adapt. You can decide you really actually hate your vendor and you're going to change, or you really want to try Grafana, or you're really going to need to perform it, like make this more performant, whatever. You've probably heard the concept of a single pane of glass. The idea here is to bring as many different aspects of your monitoring together as you can. You'll hear the 3 pillars of observability: the logs, the metrics, and the traces. The more of these things you can kind of get in one spot, the better. That makes sense, sure, but it's often hard to do when you're setting up. It takes time, it takes effort, it takes money. It's not always the quickest solution, especially if you're trying to keep out like big vendors and people that will do these all-in-one solutions for you. It's tempting to not do this. And so we really didn't when we started out, but I think this was one of the few mistakes that we made in our early sort of observability platform. And especially in our case, it was our logs. Our logs were captured automatically by our runtime. Kubernetes just takes them and stores them with our cloud provider. We had metrics set up elsewhere. It was fine. You could read the metrics, you could read the logs. It worked. The data was all there. And that was fine right up until it wasn't. The overhead increases as you get more logs, more metrics. It becomes much harder to correlate things together. So that eventually becomes untenable, and it's something you need to keep in mind when you're sort of starting out. So we obviously then pivoted into Grafana Loki, and that's where sort of Grafana starts to shine with covering all the 3 pillars. We had logs, but bringing them into Loki, changing nothing else, made them far more usable. Just being able to sort of quickly cross-correlate them with the metrics was super helpful, and teaching the devs one interface saved us a lot of time. Now, I've never run Loki myself. We've been hosted on Grafana Cloud's Loki from day one, but I suspect you could probably do an MVP with Loki the same way we did with Prometheus. Run it yourself on kind of the minimum possible setup and have the devs introduced to that as part of their like logging expectation from the get-go. So with all of these things, all these tools that you're trying to get scrappy with at the startup, your goal is to build something that at best is pretending to be a robust solution with as little actual input and effort on your part as possible. Until just recently, our entire engineering team, or entire SRE team rather, was just 3 people. Your job is to be a force multiplier for the rest of the engineering org. Every person, every tool, every process that you bring on at this point has to improve the productivity of someone else to earn their keep. So this keeps your mindset away from like overbuilding or getting lost in the weeds of monitoring. Your focus is, I have one resource. There's no way that's solving the problem itself. So how am I using this to make someone else that actually solves problems more effective? To switch gears a little bit on the monitoring, dig a little deeper, I'm going to assume that the audience here at GrafanaCon is already on board with it's important to monitor the things that you build. If you're still really early days, or this is your first kick at the product can, You might need some buy-in that, yes, you're building this thing and yes, you need to monitor it from day one. But once you even have that buy-in, the question is, what do you monitor? Generally, you have two options, everything or your best guess. The everything option is the easiest. Just wholesale every metric that gets produced into your storage. The logic here is it's too early to know what's important. You have no idea what you're going to regret not collecting or what turns out to be really, really, really important down the road. Just keep it all and let the specifics be sorted out later. The other option is to try to sort of start figuring out how to focus from day one. Pick some really high, rough service level objectives and keep the data relating to them and the surrounding. The advantage of this solution is really the cost. It's the cash cost of being cheaper to store less data, and it's the mental cost to your devs, your engineering team, and your observability platform build-out team to not have to parse through a whole bunch of unneeded data and decide what you actually want, decide what you actually need. So we went with the first solution. We just kept everything. We said we'd figure it out later, and I'm sort of two minds if that was the right call or not. It worked, it was easy, it let the devs pivot through a mountain of data when they were debugging to start off with, and then we built SLOs on top of it to refine it down. But it was expensive in both cases. It was a bunch of useless metrics that we didn't need, and that is a form of tech debt. And I'm not kidding that like the cash costs will sneak up on you. Another question that comes up repeatedly, and it's another thing that we arguably made a bit of a mistake on, but at what time do you need to start dealing with tracing? If you have a big monolith or you're deploying an MVP application that's just like one big service, you don't need tracing. Internal tracing, hairy at best. But if you're building a big distributed system like we were, tracing feels like one of those things that you don't really need immediately. It's good to have it, the three pillars, it's good to have there, but we would have to build a whole separate system for it. It costs instrumentation. Again, I think this was a mistake. I think probably we should have indexed on tracing faster. Again, Grafana has Tempo now as part of their main platform. You can do this with little build out, but the actual code overhead of writing all these traces and figuring out how to trace in a big distributed system is complicated. So make sure you get ahead of that, because when you need tracing, it's getting too late to start building it. So that's your setup. You've started, you've got your product, your main product is starting to come into the shape, and so is your monitoring setup. So I would argue that you now actually have two products. Our monitoring and observability platform was one of the first systems internally that we started to think about as its own product being offered to internal customers. The power of this mindset is it keeps you thinking about improvement like you would a product. You're thinking about how to enable your customers and how to focus on customer satisfaction, which is important. If your engineering team gets grumpy enough, they can and will start to bake their own monitoring solutions that go around the stuff you've built to get the features that you don't have. This can be really good. It encourages innovation. You find new things that you need to monitor, but it fragments your platform. And again, like I've said, the fragmentation just eats away at your overhead. So keep ahead of that. Make sure you're keeping your devs happy, listen to what they need, build the platform for them. It's also a great method to decide when it's time to start shelling out money. If you're treating your monitoring like a product, you can make a good case for when the return on investment is worth it to start hiring people or doing things. So the pace is picking up. Metrics are coming in. You're starting to notice that things need to scale. It's time to dedicate some resources to thinking about the observability platform at like a holistic view. We at Dapper Labs and Axiom Zen have almost always had the benefit of having someone whose sole responsibility is the observability platform. That's mostly been me, and that's mostly because we had other things going for us. We could afford to pay me to think about observability from day one. You might not. That's okay. If you're starting out from scratch, you don't have a full team. But you'll pass a certain point, and the litmus test for when you're passing that point is you'll notice the product vision for your monitoring platform isn't keeping up. Performance is suffering, you're running out of disk space, you're having outages, like the monitoring is falling behind, devs are getting grumpy. You don't want to panic. You don't want to throw a whole bunch of people onto this and make it like a 7-person team. You don't suddenly need to go hire like a head of SRE and like really build out a monstrous team. But you do have to have a transition in your mentality from shooting from the hip to like, okay, it's now part of our core stack. How do we think about keeping this thing up to date with the rest of it? So you keep going. At some point, you have to make some hard decisions about, hey, are we keeping this in-house or are we offloading the hard work to someone else? I almost always err on the side of pushing problems that are not our core business onto someone that knows how to deal with these things and letting them solve it at scale. So this again is Grafana Cloud. We moved our little itty bitty hosted Grafana instance to Grafana Cloud pretty early on, before we even spent much time like optimizing it or getting it performant. As soon as we don't want to run the database ourselves, we don't run Postgres, we don't run our infrastructure, we have people that know how to do these things run it for us. Giving up that local deployment and going to the cloud should be pretty smooth if you've done things right. And you kind of need to do that as soon as the value to you is not there and your additional brains you need to spend on it isn't worth your time. But there's a gotcha. No matter how hard you try to stay true to the tool, a hosted migration is still a migration, and there's always gotchas. There's always going to be some amount of headaches and misery you don't get by for free. Our gotcha in this was that our dashboards didn't survive the migration from local Grafana to Grafana Cloud. It's a simple mistake. We used Postgres as our Grafana backend. Grafana supports it. We use Postgres, easy, easy. Grafana Cloud uses MySQL as their Postgres backend. We couldn't make that switch without, rewriting the SQL to be more MySQL. It was going to be a whole thing. And in our case, we started the move early enough that actually we decided it wasn't worth the time anyways. Most of our dashboards were out of date, so we just declared them lost, abandoned most of them, grabbed the 12 we needed and just imported their JSON and moved on with our life. There's some tools to help you out here, but the important takeaway is that it's still a migration. It's going to burn you somewhere, somehow. How much, you'll have to wait and see. So make sure you get ahead of this and don't be waiting until you're busy to suddenly decide you need to do this. So now comes the fun part. You've got Grafana operating at an early to mid scale. You're in maybe Grafana Cloud. You've maybe got it yourself and have a small team dedicated to it. And then now and then, if your timing is right, your product is good, you'll abruptly get launched well over your goals and aspirations and straight into space. This is good news for your business, but it's often really fatal to engineering services. You should expect to survive a 2x or a 10x, like build your services to handle this. But no one builds to survive 100x. You just don't know what that scale looks like until you get there. But we kind of knew what that scale would look like. We'd done it before. So we overbuilt things a bit and we managed to survive the 100x. We had to rebuild a lot, but the one thing we didn't rebuild and didn't change very much was the observability. With a 100-fold increase in users, 1,000-time increase in traffic, which then turned into a 10,000, our metrics and logs just jumped through the roof. And this is one of the rare places where horizontal scaling really, really bites you. Don't get me wrong, horizontal scaling is the best, but Prometheus metrics are sampled. They can report really big swings in data with no increase to the data size. But if you bring on more services and scale it horizontally, the cardinality increases. And that in Prometheus especially is what kills you. We overshot our predictions for our Grafana active series over and over and over, and the costs came at us from kind of all angles. Our accounts team will know I spent hours and hours hashing over those contracts. And this is where our tech debt comes from. We were collecting all of our metrics up front. And we were forced at this point, when the company was super busy and like really, really, really trying to capture the success, to stop and try to think about how to trim down the amount of metrics we were doing. There was some open source tooling that helped us out here, but it wasn't pretty. It's still a trade-off. Was it worth it? Did it get us to the point in the market where we could be this lucky? It's up to you to decide. So now things are stable again. We survived being catapulted to the spotlight. We're growing steadily. In the months and years, our monitoring use is only going to keep going up and up and up. We intend to ingest more metrics, more logs from news sources, and we want to really lean into our tracing capacity now that we have Grafana Tempo merging those three things together for us. We've also introduced and instrumented the Flow blockchain with Prometheus metrics completely as standard. So as Flow grows in the future, all of our downstream users will have Prometheus metrics for free, and we will try to find interesting and creative ways to make this data available to the public. The screenshot here is a screenshot from one of Flow's development environments, showing sort of our transaction rates and our block rates. Great data to have. This also means that we're going to get into sharded Prometheus scrapers, parent-child Prometheus scraper hierarchies, reduced blast radius for failures, failovers, long-term storage, all these fun things that happen when you go from 1 to 10,000. There's a whole other talk to be had there that I'd love to give one day about how exactly we're going to scale this up to go big. So let's take a moment and take it back to the top. We've used Grafana from the smallest, dumbest deployment you can get and scale it up to survive the load we're at today without changing too much. We didn't overbuild early, but we did put in enough thought to save us from as much future pain as we could think of, while doing the best we can to mitigate our mistakes and deal with them as they come up. We treated our monitoring like a service, like we did from day one. We still to this day sell it to the rest of our teams. As the rush came, we were ready to absorb the shock. And now we have the luxury of time and resources to spend our time thinking about how our monitoring is going to look in the future, hire some more people to think about it, and really sort of go in. So that's it. That's our Grafana at every scale. I'm Andrew Burian. Thanks for listening.